Hi guys, my name is Mitch Horne. Just tell me if you can hear me at the back. So I'm pretty much an all-round JavaScript fanatic. As you can see, front-end, Node.js. Code quality has recently been my new addiction. I work for Binary Digital as a software developer. And note the E. The E is silent. Just saying. Okay, so today my topic is going to be about code quality with a specific focus on code reviews and unit testing. So moving on, what is code quality? So for me personally, I think it's a collection of tools and techniques used to improve the quality of your code to the point that you can maintain it for a longer period without having to cry every time you look at it. So some of the tools that you can use for that is automated testing, you have linters, you have your code reviews, and, well, the rest is on there. And obviously, like, refactoring, quite important every now and again. So the why. I take my cue for why the same place as Edmund Burke took his, as in the only thing necessary for evil to triumph is for good people to do nothing, and thus the only thing for bad code to triumph is for good developers to do nothing. Thus, code quality is there to give us a way to do that. So starting with code reviews, I find there are two major ways of code reviewing. That's pair programming and your tool-assisted reviews, such as your code reviews on Bitbucket and GitHub. I'm going to go a bit more into detail in each of these, but the talk overall will be a bit more high level. So with pair programming, yeah, as with all things, there's a give and a take, a good and a bad, if you will. So what I find with pair programming is it is extremely effective at finding defects really early. Because you have two people looking at the same code at the same time, both in the same mind space, looking at the same problem domain. Thus, I find it probably the most effective way, since you have a driver and you have a navigator. So your driver, obviously the coder, and your navigator looking at a higher level, thinking of how this can be used in better ways. So thus, very easy to pick up on mistakes early on. Secondly, it's great for mentoring and knowledge sharing. So especially when you have a large divide in experience between the two coders, once someone is driving, doing some code, and possibly the navigator is more experienced, he can highlight things much easier that he would not have picked up on his own or would have taken a longer time to learn on his own. So knowledge sharing, really great in pair programming. And then the last thing is it's a very tight feedback loop. So with Agile, one of the most important things is to iterate. That's how you improve. You do something, you fail, you learn, you get better. So thus you need to improve your feedback loop, get it as tight as possible. And since you literally have someone sitting next to you while you're coding and giving you feedback, that's probably the most tight you're going to get that loop. Now, as for the bad thing, you've got two devs for one piece of functionality. That ties up two resources for everything you need to pump out. That's obviously quite a time sink. You can also another quite a thing that is bad with pair programming compared to your tool-assisted stuff is everything is verbal. All your communication, all your decisions in your code going a certain way is verbal. So there's no way in 6 months' time going back to it and looking, why did we make the decision to use X library here, for instance. And also you have personality clashes, or what some people would call hygiene differences. So this could be a really big problem when you're sitting in one workspace with someone that you dislike, and let's be honest, we don't like everyone we work with. That's just a fact of life. And then the final bad thing, or not really a bad thing, but more of a challenge, is you need a change in culture of your business to actually be able to implement this, getting everyone to be comfortable and understand the reasons for pair programming. And now, moving on to tool-assisted reviews. So this also is effective at finding defects. As you have multiple people looking at the same piece of code, you could notice things that the original coder might not have either understood, known, or noticed himself as in certain mistakes. So you also have that. It's also a great mentoring tool, as you have comments which would be feedback both for reviewers and persons submitting the review. I personally can attest to this. Before code reviews, I pretty much didn't know how to program. So that's where I learned how to program, by being chewed out constantly with like 100 comments on my code. And then another benefit is it's asynchronous. So you're freeing up your resources to work on different functionality, and you submit a code review. The person picks it up at his own pace or his own time, so he can still continue with his work, thus get more stuff done. Then it is also a managed workflow. You know exactly how it works. It's not kind of a wing it as you go with pair programming. You know, you do your code, you submit a review, they comment on it, you fix whatever needs to be fixed, iterate, merge. And then lastly, it also has a tight feedback loop, because it gets the feedback on the code gets back to you before it ever reaches testing or development or production, anything like that. Now, the negatives of this. So it is, of course, vulnerable to poor reviews, as you might get a reviewer that has an off day and he just doesn't care to look at the code properly, or just someone who doesn't understand the problem domain. So it's always vulnerable to that, but you just kind of have to work at that. That's one of the inherent problems with it. Also, you can get really nasty merge conflicts, and I'm going to get a bit into that after and how to implement these code quality changes. But just to suffice to say that if you don't leave your ego at the door, it's really easy to get offended by things being said about your code. So, well, we all have our pride. And then lastly, also takes culture change, as it's not very natural to stop your work in the middle and start doing a code review for whoever asks. Now, tips on starting this thing. As I just mentioned, leave your ego at the door. So your code review is a place to learn and to prevent bugs that would otherwise be much more expensive to fix later down the line. It is going to be criticized, and there is going to be questions about it, and if you find that it's wrong, that's a chance to actually take that in and become better. Another thing to keep in mind is to not use pronouns. Try to review the code and not the coder. Instead of saying, you did this wrong, rather ask something like, don't you think we can do this in a better way? For instance, the picture at the bottom is a good example of that. So the third thing, don't be fussy. So if you're using if you're using linters, let them do the job. Don't spend your time in code reviews actually looking at styling and formatting issues. That's why the linters are there, and they do it much better than humans do anyway. And the fourth thing, is you're supposed to find the problems, not the solutions. So something that I found myself falling into quite a bit is finding something that I think I can fix really easily, spending 30 minutes fixing a review that's not mine, and then merging it. Very bad practice. You're not only wasting your time as the reviewer, but you're also taking away that opportunity from the person who made the review to learn from the mistake that you've just found. The fifth one, it's not all bad. So yes, you're there to find problems, but let's say you come across a piece of code that you thought solves something really amazing that you might not have thought of yourself, and you've learned something from it. It's always good to give your colleague a little pat on the back and like, well done. Just boost in morale. And then finally, embrace feedback. This is probably one of the most important points and goes hand in hand with leaving your ego at the door. Every comment, every problem found in a review is a triumph, and you're supposed to learn from it. It's not a criticism of you. It's for you to improve. So next, unit testing. So unit testing is pretty much breaking up functionality into smaller parts or units, and then writing automated tests for them. Now, there's one large difference between that and integration testing, which I'm having quite a dilemma with myself. Which one is better? But I'll get to figuring that out soon. So the biggest problem that I found with it is that it assumes that everything outside of the unit you're testing is working and is tested on its own. So without something like code coverage to make sure that that happens, you're kind of working on blind faith, hoping everything that plugs into this functionality works. Now, it is a debated topic, and there are a couple of people in my mind. So when it comes to unit testing, so there are the enlightened that have accepted it as the one way, those who have not yet been convinced, and those who cannot be saved, unfortunately.
This is not a religious meetup.
Okay, so the good and the bad of unit testing. So it's great at regression management, especially when you, a couple of months down the line, your code base has grown to an enormous, unhandleable size. You're adding a feature and unfortunately something breaks. This is where unit tests comes in really handy. It'll tell you instantly that you've screwed something up and you need to fix that. Also, it's an excellent explanation of complex code, especially if you follow the format of describe and it statements. If you're looking at a weird piece of functionality, you're just going to want to understand if you put something in, what does it give you out? This should help a lot. Like it should give you 4 if you put in 5. Thus, you know it minuses 1 ultimately, or something like that. Obviously, it's a very simple example, but proves the point nonetheless. And it helps tremendously in continuous integration. So if your goal is to deploy multiple times per week or as quickly as possible, then this helps as an extra check, just a sanity check before you deploy to make sure all of your stuff is still working. Now, the bad is the bit more obvious parts, which deters a lot of people from seeing the value in unit testing. It takes a lot of time to write. It can easily double your development time if you're not used to writing tests or if there are complex pieces of code to test. Then it also provides no short-term gain. The most gain you're going to get out of unit tests is a few months along the line when you're either introducing people to your code base and they can get an easier feel for your functionality, or you're adding new functions and making sure that none of the old functionality breaks. And the last thing, and this is probably the biggest flaw in testing, not really a flaw, but the biggest drawback of it, is it provides no direct benefit to your client. Indirectly, yes, by making sure that nothing breaks, but unfortunately, we cannot claim that it gives anything directly. So some tips to start on that. If you have a large code base, you want to introduce unit testing, start by covering the new stuff. Make sure that whatever functionality you add is covered. Then secondly, going systematically to cover your old code with tests. Then the third one is to set up a social contract. Now, a social contract is almost like a uniform decision of what the team values, and usually this is set up with meetings. So you'd go into a meeting, I would say, I think it's very important for us to cover everything in unit tests. I try to convince everyone. Once we are in unison, we're like, okay, yeah, let's give it a try. We come back in 2 weeks, almost like a retrospective on our social contract. If this does work, we continue with it. If it doesn't, we can revise and like, okay, maybe we shouldn't cover everything because I spent a week covering a function that was very simple to just see what it does. And it was complex to test. So we should cover everything, or we should give a good reason why we're not going to. And the social contract directly leads into creating a good culture that values unit tests and pretty much anything else that you put into the social contract, since you've got pretty much a all-around yes from your dev team. Then now for the conclusion. So I think code quality is very integral to every coding environment. It ensures the longevity of your code base, definitely. Then changing culture takes time and iterations. Just like everything in Agile, you kind of need to work at it. It's not going to work from the first time, and you're probably going to struggle for like the first 2 months or so, but it'll get better. And then lastly, I think if you have to choose between code quality tools, I would go code reviews over unit tests every day. It provides the most benefit and growth to your team and provides the most total benefit right now. Whereas unit tests will provide it long down the line, and usually when you're choosing between tools, you don't have the time to spare. Okay, cool. That's pretty much it. Thanks.